This tutorial is about curves and fillets. Say for example I want to add a semicircular tab to this flap. I'll turn on the grid. That first click gave me focus on the page. Pressing it again actually turned on the grid. Now I want to add a baseline for the tab. So I'll right click on this point and say A for add. As you'll notice, it snaps to the grid points. I press left click and left click again, and now press escape to get out of that. Now I have my baseline. I go right click at line, curve line. Now if I drag sufficiently far from the baseline, then I will get a semicircle either inside or outside. So let's have an outside semicircle. Now that I have that curve, if I want to change its radius, to select it I must click on the baseline, which is the line between the ends of the curves rather than on the actual curve. So clicking here and saying at line, curve line, I can change the radius. We don't support having radiuses greater than the length of the baseline. However, there are ways to get around that, which I'll show you later. Okay, so in addition to that, I'll add a fillet to this corner. So right click at point, fillet corner. Now if I want an exact value I can use numeric entry, and in this case I want 50. Okay, I can repeat this here, left click, Control R. Okay, so let's have a look. So just to demonstrate the opposite possibility, we can do this at line, curve line, and bring it in, and here we have a semicircular chunk out. Now given this corner here, we see that it's nice that the curve is nicely tangential to the straight edges, which is what I did manually. Now if I was to change that curve something like this, then I can actually do that process of tangential fitting automatically. So I would say curve line, and now I press period and say tangent to previous, and as you see it goes to the tangential curve again. In this case tangent next gives me the same answer. Now if I was to drag this point somewhere else, say so we're saying drag point is G, I'll drag it over here, and now we see that the curve is no longer tangent at this point. It's not tangent to the straight part. So if I go back in here and so this is the curve, as here it is, at line, curve line, and I say period and say tangent next, now I'll get a line which is tangent to this little straight bit, and pressing tangent previous I get something quite different. Okay, so In that case, there's no actual possibility of making the line be tangent to both of these straight lines. And the reason is that these straight lines meet at a point here if you extend the two straight lines, and that point is a different distance from the baseline endpoint. That one's 10 and that one, or what's it, whatever it is. Sorry, I can measure that. So that one is at 450. This one's at 400. Looking down at the bottom right. So that's 50, and this one therefore is 95. So they're different. Now we have a special method of fixing this problem, which is the two-point fit, or the two curve fit. So I say at line, fill it with two arcs, and now we have a special double curved line which will be tangent at both ends, and it also has a continuous tangent at the join of those 2 points. Now there's a further useful command involved with that, which is, supposing I drag this down here somewhere now, and so it's no longer any good. If we right click on here at point, adjust to arc corner, then we can fix it up again. Okay, so I'll just look at that in 3D, and nice and smooth. So this is a requirement for CNC milling programs. They only work on circular arcs, not on arbitrary arcs. So we've fitted the arbitrary arc using two circular ones. Now another thing I can do here is to make holes in the tab. As you'll see, it's already got a square hole down here, but I can make circular holes. So I go add machine step, hole, and click. So left clicking here, left click, and so I've made a closed machine step. That would look like a square hole. Yes, and if I do the following command, right click at machine step, round off machine step corners, then I get a round hole. So you may notice that the green here is slightly darker than it is in the surrounding area. That's because we've got we're inside of two lines. This light blue part is just the section boundary, which is used for basically for selecting the section, and the thing which you'll see in 3D and which gets manufactured has nothing to do with the section boundary. It's just a convenience for construction view. So I can also make this an elliptical hole. So I'll just go back and make it yes, back to square. And so now I'll drag this point G over here, and this point I'll do a Control R, and now we convert it again, and so machine step, round off machine step corners. It's easier to convert it back to square for that process, because otherwise you've got to drag all 8 points. So now that looks like the following. Okay, it looks like this. You can see through the holes, and the other thing I can do, I mentioned earlier that you can't make this cut out any deeper than the radius of the baseline, or half the length of the baseline. If I wanted to do that, I could actually work around that in the following way. I just say add machine step hole, take it out to symmetrical distance, and close it off. Okay, and convert that to, sorry, what am I doing? That was undo or redo. So I want to convert that to a curve. So at machine step, round off machine step corners, and now looking in 3D, we'll see a giant hole